6.5, day 1. We're going to focus on solving polynomial equations. You don't need to write these steps down. To find the zeros or the roots of a polynomial equation, you want to solve the equation for x. So the first thing you do is you set the equation equal to 0. Then you try and factor it using the methods that we learned in Chapter 5 and again in Section 6.4 in the last couple days. Once you factor it, you set each of those factors equal to 0 and solve for x. That's called the zero product property. These will be the x-intercepts on the graph if they are real zeros. Sometimes when we solve for x, we get complex zeros, numbers that are imaginary numbers. Those will not be x-intercepts for our graph. So let's go ahead and do some problems. Go ahead and write this example down. Use factoring to solve this equation for x, to find the zeros of the function. So we have an equation x cubed plus 2x squared minus 48x equals 0. And we have to think back to those methods of factoring. So what would be the first thing we would do is we look to make sure if there is a GCF or not. In this case, there is. What can I take out of all three terms? Well, I can take out an x. So I remove that x, that's a factor. So I'm left with x squared plus 2x minus 48, and that equals 0. And then I look inside and say, what other methods of factoring did I learn in Chapter 5? Well, this is 3 terms. Its leading coefficient is 1, so we're going to use the chart method or t-chart method. So to review with you, you say, what are the factors of c, which is negative 48, and that adds to b, which is 2. And so you'd start listing out some of those values. So what are 2 multipliers of negative 48? So you'd say, I could do 2 times negative 24. When I add those 2 numbers together, I get negative 22. Well, that doesn't work. So then you'd say, how about 6 times 8? We're negative 6 and then a positive 8. When I add those together, I get positive 2, which is the one I want. So there is my negative 6 and 8 that I will split up. So now I factor it as x, that's your GCF, and I have 2 parentheses. Split up the x's, and then the other 2 terms are from right here, negative 6 and positive 8. Now I have it in completely factored form. Now I'm going to use the zero product property to solve for x, to get the zeros of the function. So x is a 0 of the function, so we set that equal to 0. And then x minus 6 is a factor, and then x plus 8 is a factor. We set those 3 factors equal to 0 and solve for x. Well, the first one is solved, so we have an x-intercept at 0. We add 6 here, we get an x-intercept of 6, and then our last one, subtract 8, which is negative 8. So those are my 3 x-intercepts, which are also the roots or the zeros of the function. If we go back up, we start off with a cubic equation, so we should have to put 3 zeros. You can also check your answers too if you wanted to plug it back in. Let's go on to example B. Let's write this one down. X cubed equals 49x. We want to solve it for x. So the first thing we do is we want to rewrite it in standard form. We're setting it equal to 0. So I'm going to bring that 49x to the left. So I subtract 49x from both sides. Then I look, the first thing is there a GCF or not? And yes, there is. I can take out an x. So I'm left with x squared minus 49. Now I look inside the parentheses. What are the methods I can do if I have 2 terms? I can use the difference of squareds or the sum and difference of cubes, which I learned in section 6.4. Well, X squared is a perfect squared. 49 can be written as 7 times 7, which is a perfect squared. So I can split this up into two parentheses as x, and then negative 7, and then plus 7. If you remember, that's from the difference of two squareds. A squared minus b squared equals a minus b, and then a plus b. Now I have it in factored form, so I use the zero product property, and I solve those factors for 0. So x equals 0, x minus 7 equals 0, and then x plus 7 equals 0. So I have my first solution. Here's my second solution where I add 7, and there's my last solution where I subtract 7. So those are my three x-intercepts, which are also the zeros or the roots of the equation. All right, this is a more difficult one. Now we're changing up and writing it as a function. So we have to do an extra step here. We want to set that function equal to 0. So I'm going to replace that b of x for 0. Then I need to remember our methods of factoring. This is 4 terms. So the method of factoring for 4 terms is what we call the grouping method. So we want to group 2 terms that are alike, that have a common GCF, and then 2 more terms that are alike that have a common GCF. So I'm going to group the first 2 and the last 2 terms together. And that's in step 3. Now see if you can find out what is the GCF of the first group. Well, you should have gotten x squared. So I'm going to divide out x squared. So what I'm left with is an x and then minus 4. In the second group, try and find the GCF of that group. You should have gotten negative 3. So I'm dividing out negative 3 from those 2 terms in the second parentheses. So I'm left with x minus 4. What will happen every time when you do the grouping method correctly, the 2 parentheses will be the same, which they are. So that's your new GCF. So that's what's going to divide out. And then when you take out this x minus 4, here, you're left with x squared. When you take out x minus 4 here, you're left with minus 3. Now we have it factored. So now we set those factors equal to 0 using the zero product property, and we solve for x. So x minus 4 equals 0, and x squared minus 3 equals 0. And we solve by undoing. So we would add 4 here. So we get a 0 or a root or an x-intercept at 4. Now we undo the second equation. So we would add 3. And then notice there's an x squared. Remembering, to undo an x squared, you square root both sides. Students do sometimes forget that plus and minus in front of that square root of 3. So they undo each other, and then you have plus or minus the square root of 3. So you still have 3 roots. You have 4, and then plus or minus 3. This is a new style problem. I'd say write down either the first example on the slide or the second example on the slide. This is a new method of factoring. It's splitting up the x to the 4th term. It's very similar to the chart method. So write this one down or the next one. So we want to find the zeros of this function by factoring. So we say, what are the factors of 3, that's your C, that add to your B, which is negative 4. Very similar to the chart. You're trying to find out how do you split up that 3. So you'd say 3 times 1, or negative 3 times negative 1. When I add 3 and 1, I get 4. When I add negative 3 and negative 1, I get negative 4. And this is the one I want, the one that adds to -4. So I'm going to use these two terms. But notice that's different about this problem. It's not x squared, it's x to the 4th. So you have to split the x to the 4th as x squared and x squared. And then the next two terms are -1 and -3. Now we have it factored, so we set those factors equal to 0. And then solve for x. So we solve by undoing. So we're going to add 1 and then square root it, like we did in the last example. So we get plus or minus 1, which square root of 1 is 1. So there's two solutions, plus or minus 1. Come over to the second equation, undo here. So we would add 3, then square root it, plus or minus the square root of 3. So there are your 4 solutions. That was a quadratic equation, or sorry, quartic equation. The degree was 4, so you can have up to 4 solutions. I'm going to stop the recording and we'll pick back up.